Yes. So what we say, I was discussing with you guys. Just yes. So by using one three dicarbonyl compounds, class and type. Now this is the different one. So far we have seen one two type only. There are several examples in the one group with CC disconnections with respect to the various functionalities we have discussed. Now it goes to the two group CC disconnections. Now 1,3 dicarbonyl. You see 1,3. So 1, 2, and this is 3. So 1 and third position is occupied by the 1,3 dicarbonyl and it comes under the 1,3 dicarbonyl compounds. So how it can be chosen to be to make into the synthons? So simple is that we can break from this side. So we get the one ketone one side, and other side we can break. Already we have broken this one, so we already have the other one involved. And these both can be generated from the only one species because we have a species which contains two acetal moieties are connected via the CH2 groups. And this is the case here, very simple. Only one moiety can be used to generate both the species. So the example if we take directly for the 1,3 type, you see this is 1,3 dicarbonyl. So dicarbonyl is there. But the problem is that we have the phenyl group here is at the alpha position. So there are two pathways. One we can break from this side A and one is from this side B. So if we break from A, what happens? We get this kind of symmetrical molecule, and other is ethyl acetoacetate, similar like this one, where we have the other group, and this after the breaking of this one, we get this is a positively charged, and this will be a negatively charged. Next is that we can reverse it by B. So one side where we have the phenyl group, phenyl ester can be used as a one component, and in other side again we have the other phenyl group. You see other phenyl group. So other esters. So two esters are reacted together. We can also get this kind of product. So this is also cell. Actually, pathway B is the cell condensation. Since these are the very similar same compound, you see pH, pH, CH2, CH2, COOET, COOET. So both is same, and that's why via the self condensation we can generate the product because Claisen type of reaction comes under the Carbanian condensation reactions where base promoted reactions are there, and once you put the base, self condensation goes to form the products. So retroanalysis, how we can deal with such kind of things. This is the target molecule they have given. So in this target molecule, they have the cyclopropane ring and also have the ester molecule along with the pH. So first is that ester, which is present, can be broken and it can be generated via the reaction of acid and alcohol. This is simple esterification. सबको पता है अगर ester group है वहाँ पे break कर दो. Second step में क्या होगा कि we have the acid there, and now this is also again can be broken from this side because after the pH we can generate the negative charge via the grignard, via zinc, via copper, via lithium also. So four ways is there. You can break from here. So the negative portion will be here, and this will be the electrophilic, the positive portion. Why positive is given always to the carbonyl? Because carbon is the positively charged species. Next is that in the reverse we can just synthesize it directly. So what we have to do? We have to choose a component. This is the synthetic equivalent with this one, acid one. By reacting with the bromine in ethanol, we get the brominated at the alpha position. Once the bromination takes place, we can change the bromine or insert the metal in between the bromine so that we can get the negatively charged species, and that negatively charged species goes to attack on the electrophilic center of the carbonyl group, and it generates the CC bond followed by the alcohol. So we have the alcohol. It is very simple. Alcohols can be generated from the ketones or aldehydes. Here we have the tertiary alcohol, so it should be a ketone. And next is that how this can be treated further to get the final molecule is that this ester can be treated with the this kind of molecule. Here we have the N-methyl group and this CH2CH2, and earlier we discussed CH2CH2 group is the epoxide is very good source. So before cases what we do, we use the CC bond formation. We use the negative portion of carbon to attack and get ring get open. But in place of carbon, of course we can use the nitrogen also. So this will form the CN bond. And epoxide is not only applied for the CC bond formation, it is also applied for the CN bond formation. And finally, E is there. So this is the E. and ester, and this alcohol is coupled together by the esterification reaction, and we get the target molecule. And this is the last step we see now. So 1,5 this was the 1,3 right 1,3. So 1,5 भी होता है क्या? Yes 1,5 भी होता है. 1,5 पोजीशन के ऊपर आपको कार्बोनिल ग्रुप प्रेजेंट चाहिए. So this is the 1, 2, 3, 4 or 5. If you consider from here, but if you consider from here, this one 1, 2, 3, 4, and this is 5. So this is ester, means what? We have the ketone group there. So 1,5 dicarbon compounds also can be generated via the Michael type reactions. So here we have to see the topside ion is used to remove the acidic proton. Always same concept is there. You don't need to think about that one. And alpha beta unsaturated aldehyde or ketones, whenever you see the 1,4 addition by reacting with the Michael acceptors, where the acceptor can be the alpha beta unsaturated aldehyde or ketones or esters also, and it will generate the CC bond. And through this way we can generate the carbonyl group which is present at the first position. It will present at the fifth position also, because you see 1, 2, 3, 4 and this 5. So dicarbonyl position, 1, 5 position dicarbonyl can be connected via the disconnection approach. How we can go for the synthesis of this kind of molecule? So this is the same one. So in this one, firstly there are two ways. One way is that you can either break from A is from this side, where we generate this kind of anion, and other side we get the alpha beta unsaturated ketone here. So this is the Michael acceptor. Second way is that you can keep the other side, so B pathway, where we can use this whole moiety now. So in this one, this whole moiety is the alpha beta unsaturated nitride, and from this side we have the acetone. So acetone can be a good source of nucleophile, and this can be isolated by the can be prepared from this kind of species, and this can be prepared from this one. Actually, not this one, only this. These two reacted to form this one. From this double bond, of course, the double bond can be generated by this phenyl aldehyde or benzaldehyde treated with the acetone. We can get this kind of species. 1,5 dicarbonyl compound, Michael reactions. Again, you see this is 1,5 related compounds. So if you have the symmetric one, this is symmetric one now. So in symmetric one, we can generate from the Michael acceptor from one side and other side also, and similar from this side. So just the reverse of the breaking. If it is break from this side, this can be a synthons. If it is break from this side, this can be a synthons. But if you look at both, this will be very similar to this one, and this is similar to this one. So both is correct. But once you change to unsymmetric, now the concern for the symmetric one, you always get the two disconnections, but the both the compounds will be similar one. This is the case for the symmetric one. Try to understand the concept, what they want to say in Michael reaction itself also. If we have a compound which is symmetric enough, and in symmetric compound we can have the synthons which are both are similar, but unsymmetric one, of course, we get a different one. So here the alpha beta unsaturated ketone is the acceptor, and this is the ester which is being used here. So the CC disconnection appears from this side, and this can be also generated. The ester group can be inserted at the alpha position. So retroanalysis of other one. Now alpha, this was about, of course, if you want to understand the synthesis, you can again go this one. You can use the base to attack at this position. The esterification takes place. You can use another base to remove the proton, and this one again goes to attack at the 1,4 position to form the CC double, CC single bond. Very simple. Whatever we are discussing in reverse way, of course, we have to apply it in the forward direction. In case of alpha beta unsaturated compounds, of course we had everywhere, some places we have seen alpha beta also, but specifically alpha beta unsaturated aldehyde or ketones, how it can be generated. So it can be generated via the simple, what we can do, we can do the elimination reaction here. We see elimination. So elimination also, so this is the one way, and the other way is also there. We can directly form the aldehyde, react with the other aldehyde. So this can be a case. So what happens here? You have the paranitro-benzaldehyde with excess methyl aldehyde. What we can say, CH3, CHO, acetaldehyde. Sorry. So So acetaldehyde can be used under basic condition to form the target molecule. So what happens here, we get the acetaldehyde जैसे यहाँ पे react होता है तो double bond बन जाता है via the elimination reactions. So again another example, if we have the acids, so how we can generate it, because again double bond is there, so that double bond can be generated via the elimination, and again this can be broken to form the acid and aldehyde का reaction करके कर सकते हैं. So very simple reaction, aldehyde is there, acid is there, already take the acid there, under basic condition we get the target molecule. क्योंकि यहाँ पे क्या होता है, जैसे ही वो इसका रिएक्शन होता है दोनों का, तो यहाँ पे जो निगेटिव चार्ज जो अल्डोल रिएक्शन टाइप में दिख रहा है, तो निगेटिव चार्ज विल अटैक है and then this will get minus, oxygen will get minus, then it will becomes OH, and जैसे हम हीट प्रोवाइड करेंगे ना, तो वो OH बाजू का H, तो ये ऐसा डबल बॉन्ड बन जाता है. तो अल्फा बीटा अनसैचुरेटेड एसिड इज जनरेटेड वाया दी, we have discussed in the carbonium chemistry, after the heat generation, or if you give more heat, this will also get depart. So heat is not given, I think at room temperature itself we get the product. If we give heat, decarboxylation from terminal site also is possible. So at by the reaction of one aldehyde and other ketones, we get the alpha beta unsaturated acids. So Michael reaction and Robinson annihilation is the last portion of the retrosynthetic analysis. So usually in Michael addition we have seen the alpha beta unsaturated substituted compounds is prepared from the two different aldehydes. Either you can also prepare, this is the ring now, cyclic ring. One way is that you can use the dial solder to prepare the reaction ring. That is the best way. If you don't want to follow that one, what you can do, we can prepare a moiety where you can break in such a way that where we get the cyclic ring directly here by the aldol condensation. We see intramolecular aldol condensation takes place here, followed by the double bond generation. So this can be done. So how? सबसे पहले इसको बनाना है, अल्फा बीटा अनसैचुरेटेड कीटोन कैसे बनाएंगे, इस अल्डिहाइड का रिएक्शन कीटोन के साथ करो इन प्रेजेंस ऑफ बेस. तो अल्फा बीटा अनसैचुरेटेड कीटोन इज जनरेटेड रिएक्टेड विद द ईस्टर, अल्फा बीटा अनसैचुरेटेड नॉट अल्फा बीटा बीटा कीटो ईस्टर है ना, दिस इज डिफरेंट केस नाउ. इन प्रेजेंस ऑफ बेस, देखो बेसिक कंडीशन ये है, देन वी गेट द दिस CC1. And finally, what I have said, the negative charge will be developed by the deprotonation of alpha proton, goes to attack in the intramolecular reaction, we get the double bond here. This is the one way where we can generate the cyclic ring, and this is comes under the Michael reaction. Robinson is a different one. So this is Robinson now. If you want to understand the Robinson reaction, if you have already one ring and the other ring is generated, this is also we call Robinson annihilation or homologation reaction also we can say this one. Not homologation, annihilation नहीं है, annihilation भी रहता है वहाँ पे, annihilation. So in this case what happens, another cyclic ring is generated via the breaking of synthons. So by using a molecule where we have the bicyclic ring, you can break at this position first, where we can generate the positive and negative charges here. So negative is given here, because here we have the one proton and this is the synthetic equivalence. For negative one, of course Michael acceptor is there. By using Michael acceptor, Michael reaction का acceptor use करके Robinson annihilation reaction proceed हो रहा है, इसलिए वो combination में दिया था यहाँ पे. So this is the reason how we can synthesize it, by using Michael acceptor. The base is provided to use remove the acidic proton here, and it will get the negative charge. 1,4 addition, of course 1,4 addition takes place to generate this kind of species, and after generation of this one, this will again goes to treat with the intramolecular cyclization. This is what the reaction is there. By using a base we can generate the alpha beta unsaturated cyclic ring with the one cycle. एक cyclic ring के साथ दूसरा cyclic ring बन जाता है, उसी को क्या बोलते हैं, Robinson annihilation reaction. Another examples how we can generate something like this one. अगर आपको इसको जनरेट करना है तो यहाँ पे ब्रेक करो, है ना, ऐसे जगह पे ब्रेक करो कि वो इंट्रामोलिकुलर बन जाए. तो ये ऐसा ब्रेक करोगे तो यहाँ पे क्या होगा, एक साइड से कीटोन बनेगा और दूसरी साइड से भी कीटोन रहेगा, बिकॉज ऑलरेडी वी हैव द टर्मिनल मिथाइल ग्रुप, and this can be generated from the alpha beta unsaturated ketone, and this is also having the ester. तो ईस्टर 1,3 डाइकीटोन इज ऑल्सो देयर, एंड 1,3 डाइकीटोन का जो हाइड्रोजन रहता है उसको भी एक्टिवेट करके हम अलग अलग ग्रुप बना सकते हैं. So first step is that they have given this one first. So isopropyl iodide, this is isopropyl iodide. Isopropyl iodide कैसे रहता है? We have the two uh, groups there and iodide is there. So what happens here? They under the, so everywhere same reaction. You see everywhere. तो बेसिक कंडीशन यूज करके एसिडिक प्रोटॉन निकाल के वहां पे यू गेट द नेगेटिव चार्ज, प्रोपाइल ग्रुप के अटैक होता है, आयोडाइड निकल जाता है, तो यू गेट द सीसी बॉन्ड, एंड देन इट गोज फॉर द Michael acceptor reaction, and you get the CC, another CC bond formation है. And finally हाइड्रोलिसिस होता है, डिकार्बोक्सिलेशन भी हो जाता है क्योंकि ये निकल जाता है, एंड साइक्लाइजेशन. थ्री थिंग्स आर देयर अंडर बेसिक कंडीशन. यहाँ पे नेगेटिव चार्ज रहेगा, it will attack at this position, it will form the alkoxide followed by the removal of water molecule, it will form the double bond followed by the decarboxylation. देखो यहाँ पे हीट कंपल्सरी है क्योंकि ये ईस्टर ग्रुप जा रहा है फाइनली, यहाँ पे देयर इज नो ईस्टर ग्रुप. So through this one we can generate the Robinson product. There are some other reactions also there, symmetrical alpha beta carbonyl linkages जो रहते हैं, something like this one. तो यहाँ पे अगर आपको बनाना है तो you can use the 1,2 डाइकीटोन along with the another ketone. तो यहाँ पे ब्रेक करते हैं डबल बॉन्ड के ऊपर. तो जैसे ही ब्रेक होता है you get the डाइकीटोन and also you get the monoketone. Now this monoketone also again problem. How this is not commercial. How we can generate it? We can break it from this one and this one. So this will be the word same molecule, methyl phenyl methyl magnesium bromide. So same molecule एक ही इसके ऊपर अटैक करेगा ईस्टर के ऊपर, then it will get the stand up. तो दोनों साइड से अटैक होगा, एक साइड से होगा तो एक बनेगा, दूसरी साइड से अटैक होकर ईस्टर ग्रुप निकल जाता है. तो सिंपल है बेंजोइन कंडेंसेशन. यू सी बेंजोइन कंडेंसेशन वेयर यू कैन जनरेट द डाइकीटोनिक स्पेसीज. So by using the cyanide, so benzaldehyde is treated with the cyanide, we get the alpha hydroxy ketone, and this alpha hydroxy ketone will be gone through the oxidation by chromic acid, we get the another ketone there. So this is the first species is ready. Second way, this is what we call the conversion synthesis. We have discussed in the earlier stage. This is the conversion where the two different pathways are related to form the two different compound, and then it's coupled to form the final product. So other side we have to treat with this one with the magnesium to form the magnesium inserted compound, and then it will be reacted with this kind of ester, and it forms the alcohol again now, because magnesium यूज करके डायरेक्ट कीटोन नहीं बन रहा है अल्कोहल, बट वी नीड अ कीटोन है. तो इसका क्या करेंगे और एक बार सेम वे से, जैसे यहाँ पे हाइड्रोक्साइड का ऑक्सीडेशन करके कीटोन किया, देन दिस आल्सो गोज फॉर द कीटोनिक प्रोसेस. Now these two will go with each other and it will generate the two water molecules निकल जाते हैं. कहाँ कैसे कैसे निकलेंगे? ये ऑक्सीजन एंड दो हाइड्रोजन यहाँ पे प्रेजेंट है, टू हाइड्रोजन फ्रॉम दिस वन एंड दिस ऑक्सीजन, अदर साइड से टू हाइड्रोजन एंड दिस ऑक्सीजन. सो टू कंडेंसेशन रिएक्शन होते वी गेट द सेम मॉलिक्यूल. So this was about that one. Carbonyl condensation also there. So in this one, alpha beta unsaturated substituted ketones or tertiary alcohol ketones is or isopropyl alcohol ketones can be generated. तो हमको क्या करना पड़ेगा, यहाँ पे ब्रेक करना है. अल्डिहाइड के साथ भी कर सकते हैं, अल्डिहाइड और कीटोन का रिएक्शन. देखो एवरीवेयर इज देयर, क्लेसन कंडेंसेशन, बेंजोइन कंडेंसेशन जो हम पढ़ते थे वो अभी यूज हो रहे हैं अलग अलग मॉलिक्यूल्स बनाने के लिए, सेम ही कंसेप्ट है. And this one again it can be generated from the alkynes now. This is very important because tertiary alcohol is generated with respect to the ketone. So what we can use the alkynes. Alkynes can be prepared by the acetylene with reaction with the acetone. So first step is alkyne reaction by using sodium in liquid ammonia. We get the tertiary alcohol alkynes in presence of acetone. So second step, this one can be treated in under the silver, no Hg, mercury in water. We get this species where the alkyne is now changed to acetone. Try to understand the reaction. जैसे हम Hg2 प्लस या एसिडिक कंडीशन में यूज करते हैं तो अल्काइन का ब्रेकिंग होकर कीटोन बन जाता है, एंड दिस इज व्हाट दे हैव अप्लाइड द स्ट्रेटजी. And now after this one they have treated with the furfural-aldehyde and it forms the alpha beta unsaturated tertiary butyl alcohol. अलग अलग वेज में अलग अलग यूज करते हैं. जैसे यहाँ पे अभी विटिक रिएक्शन तो आपको पता है कि डबल बॉन्ड, जैसे कीटोन है यहाँ पे फॉस्फोनियम साल्ट रहता है, कीटोन बन जाता है, नॉट कीटोन सॉरी, ओलिफिन बन जाता है. दिस कैन बी डायहाइड्रोक्सिलेटेड बाय यूजिंग ऑस्मियम टेट्राक्साइड भी एक यूज रिएजेंट है जहाँ पे क्या होता है डायॉल बन जाता है. तो विटिक रिएक्शन का डायहाइड्रोक्सिलेशन करके भी ये कंपाउंड बना सकते हैं. कैसे बनाएंगे? फिनाइल मैग्नीशियम फिनाइल ये जो अल्काइल फिनाइल अल्काइल ब्रोमाइड फॉर फिनाइल इथाइल ब्रोमाइड treated with PPS3 it generates the salt by using a base. Use a base required. If there is no base, we cannot generate the Wittig salt. This is not complete Wittig salt. Wittig salt is generated by a deprotonation of alpha hydrogen atom. तो ये तभी जाके डबल बॉन्ड बनेगा. जैसे ही डबल बॉन्ड बनेगा तभी जाके डबल बॉन्ड शिफ्ट होगा. Then it will go to treat with this one to form the double bond. And here dihydroxylation और KMF4 से भी कर सकते हैं. We get the जैसे हम लेबोरेटरी में टेस्ट करते हैं रिएक्शन को, ऐसे रिएक्शन को बना सकते हैं. Reverse Pinacol reaction is also there. In this case, what happens? The thiol will be used by using ketone, and it forms the alpha and the spiro compound. This is the spiro compound. So magnesium mercury is used in order to form the diol. First, in benzene, देखो यहाँ पे diol कैसे बन रहा है? Not from the alkynes, it is from the ketones. So this is alternative pathway where you can generate the diol. First way is that you can use OSO4 of olefin. Second way is that KMO4, but third way is that it can be also generated from the ketones by using magnesium and mercury mixture in benzene ring. We get this one. जैसे प्रोटोनेशन करोगे ये निकल जाएगा, कार्बोकैटायन जनरेट होगा, एंड जैसे कार्बोकैटायन जनरेट होता है we get the spiro compounds. नेक्स्ट इज दैट aldol condensation भी यूज कर सकते हैं हम, एंड इन aldol condensation we can generate the products. So in this one, this is the species, this is the target one. It becomes more complex, of course, because everywhere they are applying the various conditions in order to form the products. So this one, the diketone is there. You see, this diketone can be generated via the reaction with this one. Just a moment. So now, where we were, yes, here. Alright, so what I was saying, this is very complex now. We have the diketone moiety also there and phenyl hydroxide. So what happens here, we have the diketone and also the phenyl group there. So by using the different strategies, we can generate this kind of moiety. It becomes more difficult for you, but aldol condensation is a very good reaction where we can generate various kinds of alcohols there. You see this alcohol and this alcohol. So by using the strategy, using this kind of cyclohexanone and also the diketone can be used to generate this one. Either you can use the diketone in the cyclic ring, and also in the other one we have the phenylaldehyde or benzaldehyde. So the first step is that, of course, जो भी right side में रहता है first step में आ जाता है. So this is the first one where the 1,2-diketone is treated with the cyclohexanone. We in presence of this we get the tertiary alcohol. देखो, whenever you see the tertiary alcohol, always you should have the ketone there. If there is no ketone, tertiary alcohol cannot be generated. So this is also one concept where we have learned in the basic chemistry that by using the aldehydes we can generate the primary alcohol, and by using ketones, of course, we can generate the secondary alcohol. And this is the way how we can get the products. Next is that same aldol condensation can be used to generate the alpha beta unsaturated compounds, and this is cyclic one, intramolecular जो हम बोलते हैं, in this case intramolecular can be generated. So here this can be generated via the having the diketones there. Now you see the terminal methyl group is also present, and this terminal methyl group can be used at the one of the, you can either use from this side or either use from this side also, which will generate the same product. So what happens here, you see, now this is the negative charges appeared from this one by the deprotonation, and this attacks at the internal ketonic group, and it forms the alkoxide first, followed by the alpha beta or the water molecule cleavage minus H2O, and it will generate the alpha beta unsaturated ketones. Next is that Claisen condensation is also comes under the retrosynthesis. every reaction, not only Glaser, not only aldol reactions, but every reaction what the scientist has been synthesized over the 10 decades or 15 decades, every reaction can be used to synthesize something new compounds. So this is Clayson now. Clayson में क्या होता है कि अल्फा बीटा अनसैचुरेटेड ईस्टर जनरेट होता है. So how it can be? You can either break from ketonic functional group to have this kind of compounds. If you break from the other side, you can have the both side esters. Here it was a ketone. Once we break from this side, we get the this side A. Actually, this side it is A. So ketonic group is there. And other side we have the both one. So Clayson ester condensation. This is the same reaction. Phenyl ester is used by using base. We can generate the product. देखो एक ही step में बन जाता है. You don't need to worry about. This is also comes under the something like self condensation reaction. So alpha beta unsaturated lactones, again lactones comes in the cyclic ring, we call lactone. If it is in the open ring, it is esters. So lactone कैसे बन सकता है? Of course esterification, जैसे open chain में esterification होता था, we can also generate from the esterification of this one. So this after the esterification we can isolate this one, but again this kind of moiety we have the double bond, and this double bond can be generated via the aldehydes. अगेन इसको अगर 1,3 डिस्कनेक्शन करना है तो यहाँ पे भी और कर सकते हैं फॉर्माल्डिहाइड का रिएक्शन. तो सिंपल इज दैट वी कैन यूज द आइसोप्रोपिल aldehyde can be treated with the formaldehyde under basic condition, and we can get this primary alcohol. And later on this is a reagent is used to cyclize the ring. You see esterification जो बोलते हैं हम, जहाँ पे अल्कोहल एंड यहाँ पे एसिड कंडीशन होता है, यहाँ पे दिस विल गेट इनटू द एसिड. सो एक्चुअली दिस इज ट्रीटेड विद दिस वन, and acidic group is inserting at this opposite this carbon atom. You see this is like something like 1 2 carbon only, because another carbons which are coming from this side. So that's why the whole ring is getting cyclized here. All right, so this was all about the retrosynthesis. Now anyone is having any doubt, they can ask me. There are several concepts, complex chemistry is also there. But even though I have removed a few slides because the repeated slide also will appeared after doing it seriously. Any question, Aishwarya or anyone? No questions? Yes. Actually, retrosynthesis is the way where we are using the the concept which we are learning in the first unit. Now we are applying in the fourth unit, and that's why they have kept the same syllabus in the same paper. This is the main reason. If we are learning the reactions via retrosynthesis, something like carbanion chemistry reactions, if you learn in the previous semester, you cannot remember it, and this is the reason they have kept the same content with relation to each other in the same syllabus, same paper. If you, that they can keep, of course, in the first semester also, second semester also you have some condensation reactions, but in that case that reactions is lesser, but now we have more reactions. And why they have kept in the second semester also, because in the first year also you might have to undergo some few reactions of condensation type of reactions. And after the learning in the basic in the second semester, now you are coming to the advanced level in the fourth semester, and that fourth semester now you are applying in the fourth unit, and that is for the application purpose they have kept the syllabus related the both the unit together. Retrosynthesis we are learning in reverse direction, but in the first unit we were learning all the reaction in the forward direction, and you are now coming to reverse direction, and that's why you must have to know the reaction before you study, and that's why they relate both the units together. I think it's clear now, Aishwarya, right? Any other one? Okay, I think looks like everybody understand everything very good. Now, if there is no questions, teacher will be always happy. There will be one thing that you understand everything. Otherwise, there will be second thing is that you don't understand anything. If there is no questions. All right.